Welcome! This video will cover the steps required to calculate air velocity data from pressure data using AeroFlow 2. More specifically, this video will be covering the importation of basic text file data into AeroFlow in order to compute it. In order to accurately process the measured probe pressures into flow velocity data, AeroFlow must accurately read the pressure and the associated data. The integrated Adf Creator allows the user to input data from a text file easily, with no special formatting or reserved phrases required. Before using the Adf Creator, it is important to first load the probe calibration files for the associated probe that was used to take the measurements. This can be seen under the Tools, Probe Calibrations. The probe data we'll be using for this example is located in the C drive alongside the Aeroprobe or AeroFlow installation under Example Files. You can then start up the Adf Creator, which again is located under Tools, under Data Analysis. And add our text file. Again located in the installation directory of AeroFlow under Example Files. While the Adf Creator does not require highly specific formatting, in order for it to function properly, the text file must follow some simple guidelines. The file must be tab delineated, or the Adf Creator will not be able to separate the columns. While the header before the data can be of any size, the data cannot contain any non-numeric data, as encountering a special character or letter will cause AeroFlow to treat the non-numeric character as the end of the file. Please note that this does include hexadecimal data. It is then important to make sure that the data is associated with the proper probe. This step is critical if you have calibration files for several probes loaded. After we have associated our data file with the correct probe, it is important to set the pressure units. This file uses torr for pressure and degrees Celsius for temperature, and includes no units of length. We can then inform AeroFlow as to the position of the data. AeroFlow will attempt to delineate column titles, but will simply number the columns if there is no label available. Here, column 1 contains the pressure measured from port 1 of the probe, so we can place a 1 in the slot next to port 1 minus P ref. As referenced in the labels here, AeroFlow assumes all port pressures are differential relative to the reference pressure. The reference pressure can be recorded with the rest of the data by the use of an absolute sensor, or if the reference pressure was constant, it can be added here on the side. If the pressures in the file were already absolute values, simply input a reference pressure of 0. Do note that you cannot provide a constant reference pressure and a column input for the reference pressure simultaneously. The same applies to the reference temperature. Tref is the total air temperature, important for calculating flow velocity from Mach. If the probe being analyzed contains a thermocouple and was provided with a thermocouple calibration from Aeroprobe, AeroFlow will apply the calibration and recovery factor in order to calculate the accurate total and static temperature. Additional data columns can be added, containing whatever information might also be in the file. The data in the output will all be retained up to 6 significant figures. Upon ensuring that all of these settings are correct, we can create our air data file. You will note that AeroFlow throws an error in this example case, as it was not started with administrator privileges. We can simply choose a folder to which administrator privileges is not required in order to continue. Selecting the data file allows us to see the pressures recorded in the probe, as well as our reference pressure, temperature, or any additional columns we might have added. Checking the box next to our data file and reducing it will cause AeroFlow to calculate all of the velocimetry data. Such as the Mach, total temperature, total pressure, etc. And that's how simple it is to use the Adf Creator in AeroFlow. Happy testing!